Hello everyone, welcome back to Dumbminds Presents Machine Learning for All. I am Sukresh and I'll be assisting you to learn machine learning in both theory and practical implementations in Python and Java. In the previous lectures, we had a little introduction to the types of machine learning, that is supervised learning, unsupervised learning and reinforcement learning. In the today's session, we will be learning the linear regression. Linear regression belongs to the supervised learning. Linear regression is a linear approach to modeling relation between one dependent variable and one or more independent variables. Using given data, we have to find the best fit line that can able to predict the dependent variables based on the independent variables with the least error. So our data set contains only one dependent variable and more independent variables. So here I am taking one independent variable and one dependent variable. If you can see the graph, those blue dots are the actual collected data. So that is my data set. So I have to find a line that can be at the optimum distance from every point. So with that, I can able to predict the approximate value of that dependent variable using the independent variables. This is what called linear regression. Got it right? So in the linear regression, we'll be finding the equation of a linear line that is called a regression line. If you can go to the history of the linear regression analysis, as per the evidences that we have till date, the first ever used linear regression was performed by the Legendre and Gauss for the prediction of the planetary movement in the 1800s. So this algorithm is much older than any algorithms, but it is much efficient today also. If you can see the uses of the linear regression, we'll having a lot of applications. The first and foremost thing will be the trend line. Trend line means the analysis of the previous data. So if you can take a company, you can analyze the sales of the company with the linear regression in last 2 months, 3 months, whatever that might be. So using linear regression, you can analyze the trend line. And the second thing is epidemiology. Epidemiology in the sense you can able to predict the reasons for the diseases causes. So using this, you'll be able to take all the conditions and you can find which is most influential for this disease. This is what called epidemiology. And the third application we are having is a finance. So this is definitely be a linear regression analysis application, because we can analyze the finance of a state or a company, sometimes maybe a group of people. So linear regression can be more helpful in finance. And the fourth thing we are having is environmental studies. Using environmental studies, we can able to predict how the environment is getting changed, is getting affected due to the activities of the human behavior. This can also be examined with the linear regression. And the fifth one that we are having is a machine learning. That's what we are doing. That's why we are here, right? So machine learning is one of the applications of the linear regression. So these are the one most important applications of the linear regression. As we all know, we are trying to find the best fit line, so we should have to derive that line, right? So let's start. Let us consider we have a set of points in the two-dimensional space, that is one dependent variable and another is an independent variable. So xi is an independent variable and yi is a dependent variable here. If you can see that these are the points in this graph, so we have to find a line that is best fit here. So if you can take the line here, that is y of I equals to a plus b xi. So this is the line that we want to find. Here we don't know about a and b, those are the intercept and slopes of that line. So that's what we need to find. If we find them, we can able to predict the line. So in order to do that, what is the main purpose of predicting a line, that is a regression line? The reason for this is we have to minimize the cost. Here cost is the difference between the actual value and the predicted value. So the cost function can be written as summation I equals to 1 to n y of I minus yi whole to the square. So here we are taking the difference of expected value and predicted value and we are squaring it. The reason why we are squaring it, because if the difference is squared is lesser, so the difference will be more lesser. So that is why it is called a least square method. So that's why I'm implementing it here. If you can substitute that, we can see that our cost function will become s equals to summation I equals to 1 to n yi minus a minus bxi whole to the square. I just substituted the first equation into the second equation. See, this is what our actual cost function. So in order to minimize the cost function, we must find where the first derivative of s is equals to 0 with respect to a and b. The reason why we are making the first derivative of s is the closer the value of a and b are to 0, the lesser the total error, because a and b can only make the error here, right? So that's why we are trying to find the point where a and b are close to 0. So that's why we're finding dou s by dou a equals to 0, dou s by dou b equals to 0. Let me do the first thing, that is dou s by dou a. If we can start doing derivation, dou s by dou a equals to summation I equals to 1 to n y of I minus a minus bxi whole to the square. By using the chain rule for the derivation, we can find that summation I equals to 1 to n minus 2 times of yi minus a minus bxi, and by dividing whole the equation with minus 2, we'll get summation I equals to 1 to n yi minus a minus bxi equals to 0. And we can split the summation to both all the three terms, that is yi, a, bxi. After splitting the summation, we'll get summation I equals to 1 to n yi minus summation I equals to 1 to n a minus b into summation I equals to 1 to n xi equals to 0. As we can notice that summation I equals to 1 to n a equals to n times a. After rearranging the equation, we'll get something like this: a equals to summation I equals to 1 to n yi minus b times of summation I equals to 1 to n xi by n. As we all know, the summation of xi divided by n is the mean value of x, and summation of yi divided by n is the mean value of y. So we can get a equals to mean y minus b times of mean x. So this is what the first equation we got from the partial derivation of the first equation. Let's do the partial derivation of the second equation, that is dou s by dou b. Dou s by dou b equals to summation I equals to 1 to n yi minus a minus bxi whole to the square is equals to 0. After derivating that with the partial b, we get summation I equals to 1 to n minus 2xi times of yi minus a minus bxi equals to 0. As we have did previously, divide the whole equation by minus 2, we'll get summation I equals to 1 to n xi times of yi minus a minus bxi equals to 0. Let's distribute xi to summation I equals to 1 to n xi yi minus axi minus bxi whole square equals to 0. We know the value of a equals to y mean minus bx mean. That what we have calculated in the previous partial derivation. So substitute that there. After simplifying the equation, we'll get summation I equals to 1 to n xi yi minus y mean xi plus b x mean xi minus bxi whole square. Rearrange it so that we can extract b from there, because we want to find out the b. So taking b common from the two terms, we'll get summation I equals to 1 to n xi yi minus y mean xi minus b times of summation I equals to 1 to n xi whole square minus x mean xi. So by simplifying this equation, we'll get b equals to summation I equals to 1 to n xi yi minus xi y mean whole divided by summation I equals to 1 to n xi whole square minus x mean xi. So this is what we got from the partial derivation 2. So we have got two equations: a equals to y mean minus bx mean, and the slope equals to b equals to summation I equals to 1 to n xi yi minus y mean xi by summation I equals to 1 to n xi whole square minus x mean xi. So these are the y-intercept and slope of this equation. As we have find y-intercept and slope, we can derive the line now. So this is how the line will looks like. Thank you. We'll implement this with the Python and Java in the next tutorial.